What's good, everyone? In today's video, I'm going to show you guys how to find the zeros of a function and a domain, and I'm also going to show you guys how to graph it on a number line with interval notation. Let's get started. Starting off this video, this is the first thing we need to understand when we're trying to find the zeros of a function. When it's a linear equation, we're just going to solve for x, right? So in this problem, we'd have 0 is equal to 2x plus 10. I subtract 10 from both sides. And once I divide, I'm going to get -5 is equal to x, right? So that would be the zero for this linear equation. Now, this concept changes a little bit when we get to quadratic equations where we have an exponent of 2 or 3. Now, finding the zeros is what we call factoring, right? So we do the same thing. We could set the equation equal to 0, or we could just understand that, hey, we're trying to find the two binomials that multiply to give us the trinomial. So in the first one, we'd have x minus 2 times x minus 3. And this is equal to 0. And then from this step, we would set each factor equal to 0 and get our answer. So we know x would be equal to +2 here. And once I do my second factor, I know x is equal to +3. So quadratic equation, we're factoring, set our factors equal to 0. Now, another situation where we'll see this, right? We're still talking about quadratics. Polynomials also are included. When we have a higher degree, or we have at least a polynomial with 4 or more terms, now we're going to do the same thing, finding the zeros by grouping or factoring by grouping. So we take the first two and we take the last two. And I always tell students, leave the negative sign out so that we don't have the wrong signs when we simplify. So in this first part, we could take out x squared. And let me see something real quick. This is supposed to be positive, sorry. All right, so we take out x squared. We're left with 2x plus 3. Now I go over to the second group, right? And we're going to take out 9. Do I want to take out 9? Yes. So we take out 9, and what's going to happen is these two factors are going to be positive inside the parentheses so that when we distribute this 9, multiply it back, we'll get what's inside. So we're going to have 2x plus 3. Now that these two are the same, we know we got that factor correct. So we have 2x plus 3, and then we have x squared minus 9. Just don't forget with higher degrees, right? So 3, 4, typically we're going to have that amount of zeros. Your exponent typically tells you the amount of possible zeros you could have. So we go down here, we break this one down one step further, right? And we're going to get x plus 3 times x minus 3. And now we have the zeros. We could take it one step further like this quadratic equation. So this is how we find the zeros. Now, after finding the zeros, let's say they ask us for the domain. I want to show you guys a real cool trick. And I need you guys to remember this because you'll probably never get domain wrong and range wrong. So anytime you have a linear equation, right, a straight line, and it looks something like this, all right? Or even one that's like horizontal. The domain is always going to be all real numbers. All right, mostly all linear equations, the domain is all real numbers. Now let's go over the quadratic equations. All right, because quadratic equations are the same thing. So whether we're talking about quadratics, that U-shaped graph, or we're talking about absolute value, the V-shaped graph. What typically happens is if it's a function, meaning it opens up or down, the domain is always going to be all real numbers. Okay. I want you guys to understand this trick. It's a trick. The only thing that typically changes with quadratic equations, absolute value equations, is the range, right? So let's say this point was 1, 2. So if we're focusing on the range, we know that this graph starts at 2, right? And it's going all the way up to infinity. Now let's say if this same graph opened down, right? So let's say I had the graph right here and it opens down, but now we have the same point, 1 comma 2. So now we're reading the graph from bottom to top, meaning The interval notation would be negative infinity all the way up to 2, right? So just understand that key concept. Now, when does the domain change and we have to use specific numbers or it won't be all real numbers? I got you. Continuing with domain, this is when domain changes and you will not see all real numbers. So anytime you have a segment, right, where there's an open circle, closed circle, right, there's not endpoints or arrows, I should say, that means that the domain is going to be in between, or it's going to be the x values in between these 2 points. So this is when you see one of those maps or diagrams, right? Something like this. You list all your x's and then you list the y's. This would be your domain, whatever falls on the line. So make sure you understand that. Now, what is the difference between this domain and this? Well, typically with this, right, we have an endpoint with an arrow. This means that whatever this x value is, domain is going to start here. And if it's a closed circle, we have a bracket. If it's an open circle, parentheses. Very similar to inequalities. So our domain is going to be whatever this point is to positive infinity, right? Now let's say it was the other way around. What does Mr. Peters mean? Let's say the point was like this, drawn to the left, right? And this is our plane. So let's say this point right here is negative 1, 1. So my domain, right, we read the graph from left to right, will be negative infinity up to negative 1, right? And that will be the domain. So now we talked about when domain will change from all real numbers for linear equations. Remember these 3 examples. Now let's say if we take this concept now and we're talking about quadratic equations. I already told you guys, if that graph opens up, whether it's a V or a U, or it opens down, the domain is always going to be all real numbers, right? But now let's say if in this example, that was our graph. What is my domain? First off, this is not a function. We need to know that. 2, the domain is just 0 to infinity, right? There's no graph on this left-hand side. Now, let's say if I moved, I had another graph right here, right? And I asked for the domain. And let's say this point is negative 2, negative 3. Now, my domain would be negative infinity all the way up to negative 2, and that is our domain. Right now, we're not worrying about the brackets or the parentheses. We're just trying to understand all real numbers versus a specific domain. Now that we understand that, let's talk about finding domain when we have fractions and square roots. Really hope you've been enjoying this video so far. If you have, comment down below, smash the like button for us. So now we're on to the section where we're talking about domain of functions with that have fractions and square roots radicals. So what we need to do, right, if we're talking about the first example, is we're going to set this equal to 0 and solve, right? X plus 4 is equal to 0. We know that x cannot be equal to negative 4. Why? Because if we have a 0 in that fraction, it's not going to be a function. It's going to be undefined. So any other value is going to work apart from this. Now, how do we express this as an answer in interval notation? Well, let's think about the graph, right? I'm not going to number it too much. We know that the answer is not included, right? Because it can't be. So we're at negative 4. We know it's an open circle, and we know x cannot be equal to it. So it could be any other number. So we're going to have an arrow running this way and an arrow running that way. So what does this translate to? I'm glad you guys asked. Basically, we're saying that x is less than negative 4 or x is greater than negative 4. And if we want to do this in interval notation now, right? Negative infinity, comma, negative 4, right? Parentheses because it's an open circle. We're going to use in union with, right? That's basically saying or. and then we have -4 to positive infinity. So this is how we would solve for the domain, graph it, and then do the interval notation. All right. So with this said, that's the first example. Now let's go over to when we have radicals, and radicals is a little bit different. So what we're going to do is just focus on the radical itself, right? And what we want to do now is we're going to create an inequality. So we're going to have 2x minus 8 is greater than or equal to 0. If you're wondering why, we cannot have negative numbers under this radical. So we have to make sure the answer, whatever we simplify, is a positive integer. Okay. So now we go 2x is now greater than or equal to positive 8. We know x is greater than or equal to positive 4. So now with this step, how can we graph this? So let's draw a number line, right? Keep it short. Difference between this, our answer is included. So we're going to have a closed circle and we're going to shade towards the right. Now let's say we're talking about interval notation. This changes now because we're going to have a bracket. So let's get some more space. My bad, guys. It's too much going on. Let's get a little bit more space. All right, so at this step, interval notation will have bracket 4 to infinity. Infinity will always have a parentheses. Now, let's say we do set notation. Remember that set notation always starts off the same. We're going to have these braces. We're going to put our variable. We're talking about x such that, and then we put our inequality. X is greater than or equal to positive 4. And then we're going to close this back now. Set notation, interval notation. This is how we properly graph. Now let's say if we go to this other example, and the reason why students will get this mad is because of one simple inequality rule. So we already know we have to set this equal to 0, well, greater than or equal to 0. So now I have 7 minus x is greater than or equal to 0. When I subtract 7, I have negative x is greater than or equal to -7. Guys, please remember the x variable cannot be negative by itself. So when I divide by -1, I got to do the same thing on the opposite side of the equation, inequality, right? And now we have x is positive and 7 is positive. Just don't forget that when you divide, or when x is negative and you turn it positive, you have to flip the inequality sign too. So this should be my final answer, okay? And when we go ahead to graph this, hopefully you guys can see this. We'll have 7 right here, close circle again. It says x is less than or equal to 7. So it's going towards 0. And this is our graph. If I now want to do set notation and interval notation, this is what it's going to look like. I'm going to have, put our braces, x such that x is less than or equal to 7, close my braces, and then interval notation is negative infinity to 7, and we have to make sure we have a bracket because our answer is included. But before we go, there's one more thing, one last concept I want to touch on with this. So let's say we go back now, right? And I'm going to use one of these problems I just used to keep it simple. Let's say with this example, hold on. Oh, yeah. So let's say we had an example like this, and now they put a term outside. Guys, I want you to understand that that's not going to change the domain, okay? You would still focus on what's under the radical and set that equal to 0. This is kind of like a stretch or compress, is going to stretch or compress the graph. So don't fall for this trick. If they put a number in front of the radical, you're still going to set it equal to 0 and figure out what your domain is. Really hope that this video on how to find the domain of a function and the zeros of it was helpful for you guys. Smash the like button for us, subscribe to the channel, and leave comments for future videos you guys would like to see on our channel, or if you had questions on today's video. Thank you guys for joining.